Welcome all to the last talk of the summit. I appreciate you sticking around to listen to my commitment issues. That is the yellow brick road to secure code. This talk will be themed around the musical movie Wicked, so be prepared for a moderate amount of references. So first, who is this talk for? Well, for one, it's absolutely for developers, engineers, or any code-curious persons. And this talk is also for those who may have neglected their AppSec portion of their security shop. Now, before I tell you who I am, I have to say, I am not speaking on behalf of Mandiant, Google, or Alphabet, and the recommendations in this talk are my own, and not that of my employer or previous employers. Any tool or technology recommended is not necessarily an endorsement, but a tool that claims what it does very well, in my opinion. Okay, so now that that's out of the way, who am I? Well, I'm Jordan. I do defer, and I'm a Windows curious consultant with Mandiant, now Google. I was a prior Govy. I used to do incident response for Department of Homeland Security CISA, and I was an analyst for the DoD. Prior to that, I got my bachelor's and master's in computer science from the Florida State University. And my paper plate award is always, I'm a wannabe computer nerd. So that's a little bit about me. But let's talk about you and why you should care about writing secure code. Well, for one, I know that for me, when I finish cobbling together a Stack Overflow program, I am most certainly showing it off to everyone and anyone who will see it. And the one thing I always like to point out is that in some form or fashion, it's made with secure code. Second reason, the US government. The US government is coming for you, or at least they say they are. So the last couple of years, we have seen the government wanting and putting in writing that they want to go after software companies when their customers get breached due to insecure coding practices. So don't let this be you. Write secure code. And the third thing is OWASP top 10 risk lists insecure code as a top reason for breaches. So as a fun little adage, don't let it be your code that's the reason your company gets pwned. And so I'm a realist, though. We talk a lot about secure code, and there's a lot of words, but like, what does it actually look like? Well, let's dissect some of this for a bit. And if you guys take a look on the screen, it looks just like this. Insecure and vulnerable functions that have the potential to be used for evil. But as a consultant or security shop talking to SWEs or engineers, how would they know it's actually insecure? Well, maybe they actually do know it's insecure code, but they were just writing a quick proof of concept to get that idea off the ground or funded, and they used that excuse to not follow secure best practices. That's not a good excuse, and you should write secure code. Another way they would know is by following a secure coding framework to have secure practices to kind of base their work off of. Or even paired programming, right? Pair programming, when we talk about it in like computer classes, is usually you go to the senior developer and they kind of look over the code. Or even it's someone who's at your level and they have the same know-how and understanding of what you're coding, and they try and help. But really, in my head, pair programming, when it comes to application security, it doesn't necessarily have to be with a senior SWE or engineer. Sometimes it just takes another person with a different life experience to recognize, oh, that Angular JavaScript from care code function is notorious for accepting malicious care at input from attackers to gain remote code execution. And then you would respond, thanks, man, that was a lot of words. And then you go back and fix your code to parse out any care at function calls. But another way you would know is by running your code through a built automated CI/CD pipeline, including different tools like SAS, DAS, those secure dynamic application security testing programs that have been mentioned already. Or the absolute worst case scenario is hackers blogged about it on the dark web, and that cyber threat intelligence your security org pays for found it online, and they sent you an ASCII-gram to let you know. So as you can see, there are a handful of ways you could know or would find out your code is insecure. But let's kind of put that aside for a second and give you my definition. So in the theme of Wicked, we're off to see the wizard. Secure code, as I see it, is a super amorphous phrase that has been written about by many organizations, but their definitions always seem to fall short of any meaningful content. Instead of suggesting secure code, I think it should be better defined as an umbrella term for an ever-evolving list of secure practices to perform during the iterative software development process. Now, in my few working years, the wisdom I've gained has brought me to the conclusion that the reason why the phrase secure code has stuck around is because standards organizations can't put my definition on a laptop sticker. So instead, we have secure code. So that was kind of the precursor of this talk. And now that that's out of the way, we're kind of going to get into some instances that I have seen in my time doing incident response, as well as being in security operations centers, and also the various surrounding jobs of that a SOC will do. And so these stories are a mix of multiple investigations I've done with some creative licenses in order to best anonymize all the players and risks involved. And remember, in each case, I'm primarily focusing on the application security aspect. So without further ado, the first case involves Emerald City. A flawed application was built by a contractor for the city who ended up getting breached due to poor user input sanitization of the application. The next case I'll talk about is in Munchkinland and how a developer had his developer environment instance open to the internet, which allowed attackers into the environment. And then finally, at Chiz University, Dr. Dillerman's impetuance for his small class sizes drove him to build a very insecure solution to his problem. So, the background. The Emerald City government offices were breached by an unknown malicious actor whose initial threat vector turned out to be an internet-connected billboard. As part of a new effort to generate revenue for the city, the Wizard commissions a government contractor to create and maintain this billboard service. Unsafe code practices due to a rushed Q4 deadline created a vulnerability in the software for a code injection attack. But thanks to the organization's excellent automated defensive capability, the threat actor was quarantined and kicked out the moment they attempted to move deeper into the environment. Even better, the city's complete logging and magical detections were able to tell their security operations center, the SOC, exactly what happened. Our incident response team was only called in after to verify the threat was truly gone. So, with the background out of the way, let's look at the facts of the case. So the facts were the city had a robust CI/CD pipeline consisting of Sneak's SAST, Trufflehog, and even had some grepping for sensitive strings. However, the city did not give the contractors access to their internal GitLab instance, so none of those secure controls were ever applied before these applications were put to production. Now, the city did not mandate any secure design framework, so no secure framework was used. The billboard application was written in C++, and while convincing with the city SOC, we learned that they ran their SAST tool, which told them the contractor's application had a format string vulnerability. And the vulnerability was found in the billboard's display functionality that took user input to change the messaging on the billboard with ease. So the culprit was a stir copy function, innocently used to copy strings from one variable to another. However, the threat actor took full advantage of that. And this is just one risk in not using memory secure languages, but more on MSLs in the next story. So getting back to this, per the government requirements, the application had to have debug and error logs sent directly to the city's central security server. Because of this mandate, when the app's debug logs hit the central logging server, an automated process immediately ended the threat actor's user session, blocked the IP, and forced a password reset of the compromised user, all before the SOC was even alerted. This just goes to show that how even when you do most things right, you could still be breached. And talking to the security folks in the room now, the big lesson here is to make sure your security coverage is complete, regardless of deadlines or employee machine types. And another thing, though there were government requirements which demanded application logging, if the Emerald City government were to use this secure software design framework, they would have just had to follow PW Section 1.3, stating support for using standardized security features and services, like SaaS services, is required. So now the second story. Next, we have Bach and his blunder. You see, Munchkinland's leader, Nesteros, had a new policy initiative to secure the upcoming elections. She tasked Bach to create an application that would dynamically track the inventory of voting machines. There was also a requirement to check out machines to tell which machine was being analyzed at a given time and by who. Think of it like checking out a book from the library. Now, Bach wanted to see what his application was telling him, so he decided to build a simple dashboard and run it with the Apache Tomcat service. And we'll explain about that in a second. But first, Bach's application was written in Rust. Now, Rust is considered a memory-safe language in its ability to combat, for example, use after free vulnerabilities with Rust built-in borrow checker that generally assures memory and concurrency safety. I am here to tell you today to switch to memory-safe languages. And MSL defends against, you guessed it, memory safety. And so in 2013, Android reported 85% of security vulnerabilities on their platform resulted from unsafe memory accesses, like invalid pointers, to even not cleaning up dynamically allocated memory for sockets after use. And now for the sad facts. Soapbox over. Munchkinland used the code framework KISS. That is, keep it simple, stupid. Yes, that was actually the official term the client used. And in their eyes, it meant no overly complex functions where code readability and documentation was priority over all else. And I want to note that I do not endorse that framework, but it was used. Thanks to some quick intel sharing from our partners within my organization, our incident response team was dispatched when we were alerted to a known advanced persistent threat group who had been dormant for a while, but they'd recently become active and were scanning Munchkinland's network. So we immediately engaged with their SOC to review their security logs. Like in the prior incident of Emerald City, the application logs revealed a lot of great evidence to piece together what happened so far. Though in this case, it was actually the Tomcat server logs which were able to help us gain visibility into the situation. So what had occurred was the threat actor curled the Tomcat's /doc endpoint by our APT IP's address. Now, often attackers will check versions to identify exploitable vulnerabilities before launching those attacks. And this is exactly what happened, where one of the queries that you can fake see in our little GCP console to the right found the curl command, and we immediately got to work. So once our team found this artifact, we saw the attack unfold right at the logs. And we also figured out how they got in. It was Bach's Tomcat server that was super, super outdated. So in fact, the security vulnerability here was actually in the development environment. It was running the latest Debian operating system. However, it was also running a very old version of Apache Tomcat. Now, I did say this was in the development environment. However, it was most unfortunate by the fact that this server in the development environment was being used as a health dashboard for both the applications running in dev and in prod. So to get on one more soapbox for a second, having a secure development environment is yet another important aspect in outputting secure code. A quote I like to always think of is everything is prod. And just because it's called the dev environment does not mean it is not running in the company's production environment. The only difference is it's not a final product delivered to the clients, but it's still a system that's turned on. And that, I promise you, is enough for an attacker to take advantage of. And that's a little spiel. So as for incident comps, well, this is where it gets fun, because the story goes like this. That there was a tier 2 that alerted the SOC lead, who then hit up the Eng lead to ask SWE 2. Turns out SWE 2 was Bach. And they tried to contact him on what was going on, since his name was listed on the internal tracking spreadsheet as the web server's owner. Well, with no reply after an hour, it turned out that Bach quit his job due to a fallout with Nesseros a couple weeks prior. And SWE 3 now is the correct contact for whom, of course, had no idea the Tomcat server was so out of date. And unfortunately, and partially due to the precious time lost in this miscommunication, our own threat intelligence found many of Munchkinland's residents' tax information leaked onto the Yellow Road website. And so, for my last story, Shiz University. So, Shiz's history professor, Dr. Dilliman, had a decline in enrollment in his classes the last couple of semesters. To address this, he decided to write a .NET application using his elevated admin account to query the domain controller for any new student accounts that appear. And then what would happen is these new students would automatically get sent a personalized email convincing them to sign up for his animal history course the following semester. One day, unfortunately, as many times it happens, the professor clicked on a phishing email where hacktivists were able to take over his system. So the facts. My team was called in just after their Security Operations Center, the SOC, was alerted to a large amount of data leaving their network. My team was called in to figure out what that data was, where it came from, and was it even important. So to back it up for 1 second, Dilliman actually took a couple coding courses recently where he was taught to use the secure coding framework. So he tried to follow some semblance of NIST SSDF, but when it came to keeping in line with university account usage guidelines, he simply ignored those and badgered the SOC to allow list his entire box and provide him with an even higher elevated domain admin account. So his application would have full access to everything, and the professor would just stop annoying them. This really happened. The sad facts. The professor's tool was written in .NET. This is not considered a memory-safe language. Now, in attempting to write secure code, he actually included an XOR function in one of the secrets. Unfortunately, that XOR was hex 0. This is what we in the industry call security by obscurity. And for a myriad of reasons that I won't get into in this talk, it's not advised. This is not considered a secure coding practice. Now, jumping back to the IR. While conducting a review of the application logs, they revealed the string 192.168.13.37. And it said, this IP is DC, as in, hey, here's exactly where the domain controller is. Now, this is bad for a number of reasons, but the most important one for this talk is it's considered too helpful of logging messages. Now, this is something, both logging and error messages should really be considered when you are writing them. And we'll get into when you should be having these discussions in a second. But this is something that you should be discussing with your security team, and hopefully, possibly during even security reviews or even threat modeling, because it's of my opinion, and my opinion alone, that at the very least, each application built, especially those that are internet connected, should have some sort of security review to go along with them. So, but during the IR, we were able to piece together that the professor's application was instrumental in the threat actor's attack. So it actually turns out the attacker realized Dilliman's special privileges, and in order to better blend in, they actually modified his original code to add new malicious capabilities to the professor's binary. This was confirmed by our reverse engineers, noticing distinct additions with every new executable dropped. And by the end of our investigation, we saw the attack. We saw the attackers exfil the data, which unfortunately was faculty and staff's personally identifiable information. That was the hundreds of gigabytes of data. And even worse, on their way out, they defaced the school's website with their anti-animal sentiment. It was very unfortunate, and many fines had to be paid. But so, let's recap everything. If there is one thing that I hope you get out of this talk, it's communication is key, whether it's during an incident, whether it's preparing for an incident, or it's just conversing with everyday colleagues. Earlier today, there were a lot of great tips and suggestions of really talk with your SWEs, get to know them, or at the very least, talk with those project managers, because project managers, for example, are driving a lot of these design decisions, but it's also just a friendly thing to do, right? Someone earlier mentioned also walking into those kind of engineering and planning meetings as a security person, and people are automatically scared and tense up. Don't let that happen. Be kind of prepared for even those meetings and just go talk with them. Hopefully, maybe you're in office and you can just swing by their desks. You're not necessarily pestering them if they don't seem like they're really focused on anything, or even if they do, ask them to grab coffee, ask them for lunch. But communication, to get back to my point, communication is super important in secure code. So whether it's in the gathering requirements phase or setting up agreed upon processes, like that all-important CI/CD pipeline, because even if security puts in as many tools as possible, and it will catch everything, there is a chance it may also slow down their production, their development process. And if that becomes an issue, then you'll hear, again, like other stories today, of just engineers or developers or whoever circumventing them with some sort of shadow IT. And communication also needs to be clear. It should also be defined as clear and accessible documentation, whether that's policy and procedures or just the actual documentation of the code. So the next point, I mentioned some secure coding frameworks. There are plenty more out there. And if your organization doesn't have one established, start one. And if that's not possible, I have 3 checklists here that I recommend developers use as they begin to build out new systems, or hopefully revisit legacy projects and maybe spruce them up a bit and give them some love. Next, writing code in a memory-safe language. This provides a great safety net for developers, though this should also be paired with good unit tests, as well as using assert-like statements, regardless of language. Also, these applications should send their logs to a centralized remote logging server, while of course still keeping in mind that idea of sensitivity, as in who will be reading these logs, and am I giving away too much that's not necessary for the application to work or be debugged? And this should also be done alongside a security review and or a threat model. So next is the CI/CD, that continuous integration and continuous development process. It should be baked into all compilation processes, or at the very least, when pushing code to the organization's SVN storage. That pipeline should absolutely include SAST and DAST tools that will hopefully also give active alerting and active feedback. I personally would even go so far as to truly wish, that if a CI/CD pipeline finds a severe enough bug or vulnerability, that the pipeline would just not allow the binary to be compiled, or for the branch to be merged. And then another takeaway should be the all-important development environment. So it should be created, hopefully, with your security team. However, security should not be necessarily driving that process. I would even suggest maybe having gold images of what each individual's development environment should look like, at least at a base level. Um, of course, if it's feasible and applicable to your environments, that's not a blanket statement by any means. But as always, patching everything, including the development environment, should be made with the best or with a sincere best effort. And so lastly, threat model as many applications as you can. This is a great exercise that ties with my first point about communication, as these models should be built, again, alongside the developers, and it should also be baked into that planning process. Hopefully, this is done even before any code has ever been written. And so lastly, just some honorable mentions at the bottom. I'd highly recommend you check out She-Hacks Purple's DEF CON 32 talk on maturing AppSec programs. I think there's a lot of valuable insights for both developers and security orgs out there. And then last, there is no talk in 2024 that can be complete without some mention of artificial intelligence. So whether it's being used as in a generative sense or an analytical sense or an agentic sense, I think the use of AI is valuable for seeing things unseen. I look at it like a quote from Albert Einstein, which is, as our circle of knowledge expands, so too does the circumference of darkness surrounding it. Meaning the more we learn we don't know. And I think AI is a really great tool to help computer curious folks expand their knowledge base. And so with that, thank you so much for listening to my talk. Thank you to Black Hills and Antisyphon for giving me the opportunity to talk to you all today. Thanks.
Thank you very much for being here and sharing your knowledge with us, Jordan. Very much appreciate it, my friend.
Thank you. Thank you.
Yeah, it went over well, dude. Loved how you brought in the story with everything too, man. That was awesome. It's great. So if anybody has any questions for Jordan, y'all can throw them in the chat. We are paying attention, so don't hold back. Love to hear from y'all.
Yeah. And just one point I kind of want to hammer home. At the end of the day, when it comes to just being a part of an organization, I know I mentioned communication being key, but I also think just being kind to people, and always assuming every problem or every interaction with someone as just start with thinking that they, everything's with good intentions, because at the end of the day, you're all one team trying to make something better, whether it's for your shareholders or society, that's a different story, but you're trying to make things better. And so teamwork and communication, I think, are most important.
I definitely agree with that. And empathy can take you a long way in this field, for sure. No, so just going along the lines of communication, just empathizing with people. If somebody's coming at you angry, get angry with them. About what they're angry about. Don't be angry at them, but be angry about what they're angry about. When you empathize with people in those ways, it actually helps diffuse the situation many, many times. It's a
Yeah.
great tool in your toolbox, if you will, when it comes to communication and working with people.
Yeah, absolutely. Absolutely.
Just another, oh, here we go. Here's a question that came in. So what is your take on buffer overflow vulnerabilities on C++ language? What are some of the mitigation techniques, or can they be ignored?
Yeah, so great question. So for one, I'll actually take a page from the pre-show banter that was at the beginning of the summit, where they kind of discussed about this, where a lot of these vulnerabilities have been kind of mitigated, whether it's by using those memory safe languages like Rust, or also just with the rest of your security stack. So um, I wouldn't necessarily say they should be ignored, but I do think that shouldn't be your focus. I think your focus should be sticking with some agreed upon um, line of development. So a secure uh, development, a secure code lifecycle and framework, um, and kind of take it from there. Because by following those kinds of best practices, I feel like when you look at the nitty gritty kind of buffer overflows or um, integer overflows or format string vulnerabilities, um, those all kind of disappear the more you just focus on a complete and holistic approach rather than nitpicking individual attacks and vulnerabilities. But yeah, thanks for the question.
Mhm. Thank you for answering. And does anybody else here have any other questions for Jordan? And what's the best way to get a hold of you too? People wanting to
Oh,
connect with you.
apologies. It was on my who am I slide, but it's just trust and verify. So it's spelled a little leet speaky.
Jordan, thank you, man, so much for being here and sharing your knowledge with us. I've been saying this all day, but I really do appreciate y'all coming here, joining us, and really, giving back to the community. It means a lot to us to have you guys here and be able to do this with us.
Yeah, absolutely. Thanks for having me, and really thank you guys for doing this.